Okay, college algebra class, we are looking at 3.4, solving quadratic inequalities. So we are going to just basically understand the concepts about quadratic inequalities, solve them by, well, graphically is probably, I think, the fastest way to do it. We'll talk a little bit, there is going to be symbolic parts to that as well for finding the boundary numbers. Okay, so a quadratic inequality, it's going to be a quadratic equation, except rather than an equal sign, you'll have one of your four inequality symbols. And it says the first step in solving a quadratic inequality is to determine the x values where the equality occurs. So in other words, solve the equation first, and you'll usually get two x values typically. Maybe you just get one. But those are your boundary numbers, okay? And those are going to be a real important part of the answer, but not the only part of the answer. Okay, so graphical solutions, and I am going to kind of focus on this. We don't have to graph our parabolas in great detail, but if we just know where it crosses the x-axis and if it opens upward or downward, solving the inequality at that point becomes really pretty easy. So here it says the graph of the quadratic function opens up if we know we have a positive a value, and x-intercepts are -2 and 3. Okay, so they've got that labeled here. Although they made a mistake. Let's get rid of this. They screwed this up. That wasn't right. We can see from our solutions are -2 and +3 here, and if we factor this out, x squared minus x minus 6 equals 0. If we factor that out, we would have x minus 3 and x plus 2. So our boundary numbers, and we're going to talk a little more about this, would be 3 and -2, and that's what they have here, right? And if we actually graph this entire parabola, we put y equals that, we would see a parabola that looks like this. Okay, so what we're going to be looking for now, actually, here, rather than it being an equal sign, let's say that it was a less than sign, right? Instead of an equals, we had a less than sign. For solving that, it's really not much more difficult, but what I want you to visualize, because I think this is really the fastest way to get the solutions here, rather than testing. You can plug numbers in, like you can pick a number in this interval that's less than -2, a number that's between -2 and 3, and then a number that's greater than 3. But if you know what the graph looks like, you don't have to graph it in great detail, but if you know the x-intercepts and that it opens upward, and we're looking for where is this parabola less than 0, the part where it's less than 0 just means where is it below the x-axis. That's this part right here. And then we just want to talk about the corresponding x-coordinates for each of those y-coordinates that I just highlighted, and that would be between the two numbers, -2 and 3, between those x-intercepts. So my solution set would be -2, comma 3. And because it's not or equal to, I would just go parentheses. The other thing you could do, just like this, between -2 and 3. So we could have, I guess, the set of x such that we could put it in set builder notation like that, but probably easiest just to have it in interval notation. They tried to show us that here, but they picked the wrong two numbers for whatever reason. Okay. So, so now we've got the same equation, but this time, rather than less than, they've got greater than. So I just want to highlight this as well. So if we're considering the graph of it, which looks like this, x-intercepts of -2 and 3, and we showed that on the previous example, we factored it and found the x-intercepts. We know that it opens upward. So where the vertex is isn't necessarily super important for solving these inequalities. We really just want to know where does it cross the x-axis, and is it opening upward or downward. So now on this one, what we're looking for is where is the parabola above the x-axis. That would be this branch and this branch, okay? And then the corresponding x-coordinates for those go this way and this way. So our solutions then would be what I've highlighted here. So we know that this starts over at -infinity and ends at +infinity. So what do we got? We've got -infinity to this x-coordinate, which is right here, -infinity, -2. And then we skip these ones in the middle, so that's why we put the union. So our solution set is the union of this interval, and then jumping over to 3 to +infinity. Okay, so typically, when you have a greater than, usually that's going to mean that, well, if it's opening upward, then we're going to have these two intervals. It'll be disjoint. But if it's opening downward, it kind of flip-flops, and we'll look at those too. Okay, so right here, we've been given the graphs already, but okay, so if we solve each equation or inequality, so first of all, for part A, just solving the equation, your best bet is to try to factor, and I think most of the examples in here will be factorable. And so let's see what we can do. Because it's 2x squared, we have to say 2x times x. And let's see, negative 2 would have to go negative 2, positive 1. And then remember we want to check. This is positive 1x. This is negative 4x. If I add those, negative 4 plus 1, I get negative 3. So that's correct factoring. And then my solution set for the equation part of it would be, so if I set this equal to 0, 2x plus 1 equal to 0, I'd get negative 1/2. And if I set x minus 2 equal to 0, I get positive 2. So those are my x-intercepts, negative 1/2, positive 2. That's where the parabola would intersect the x-axis. Now, for part B, where it's saying, okay, now tell me where, where does this graph, where is it below the x-axis? Where is it less than 0? Okay, so highlighted in pink, that's the part of the graph that's below the x-axis. Between those are the corresponding x values. So between negative 1/2, positive 3. So my solution set for part B would be negative 1/2, comma 2. I'm sorry, I think I said 3. It should have been 2, right? So just between those two x-intercepts, all right? For part C then, we're asking where is it greater than 0? Okay, so the green part is highlighting the part that's above the x-axis. Corresponding x-coordinates out here and then over here. So again, we'll have like that disjoint number line. So starting at negative infinity, going to negative 1/2, and then starting at positive 2 and ending at positive infinity. So I would have negative infinity, comma, negative 1/2. And then union, we'd start up again at 2 to infinity. Okay, so that's everything. So part A is just solving the equation. You just have two answers. That's it. When we're solving inequalities, we're going to have intervals for our solutions. All right. So just kind of step by step. First thing, we want to put it into this form. If sometimes they might have some of the parts on one side of the inequality and some on the other. So you want to get all your terms on the left side. Typically, I like to have a positive quadratic term, so it makes it easier to factor. Okay, so we're going to get it into this form, and then we want to solve sometimes they call it the related equation. So just factor it out, solve it, find the x-intercepts. Those are your boundary numbers, right? And then we're going to use those boundary numbers to separate the number line. Now, like what we were doing, and I still like to, not only just, so like if you have a couple boundary numbers, whatever they are, say negative 2 and positive 1. And then if I know that it opens upward, I usually just kind of sketch something. It doesn't have to be perfect, but just so that okay, well, this part here is positive, this part here is negative, this part's positive. Then it makes it real easy. If I'm looking for where is it less than 0, then I'd give between these two x-intercepts. If I'm looking for where is it greater than 0, I'd be doing the negative infinity to this number and so on, the two intervals there. Okay, and that's basically what this is saying. This is testing values, but if you sketch your graph, you're going to be able to quickly see what the solution set is. So let's see if we can solve this one. So we do need to put it into that standard form. So move your constant and linear term to the left side. So it'll be x squared plus x minus 2 is greater than or equal to 0. And then we're going to just solve this. We can say solve the, related equation. You don't necessarily have to change it to an equals, but let's factor it out. X times x, and then we're going to go positive 2, negative 1. So my x-intercepts are going to be negative 2 and positive 1. And now, like I said, I really like to sketch the graph. Let's go. So we got negative 2, positive 1. And really, I don't really care about my y scale or anything. I just know that because I solved it like this, positive quadratic term, it's going to open upward. So my graph is going to do something like this, right? And what's really important is that I know in this interval right here, this interval here, I've got positive function values. So this part's positive. In between negative 2 and positive 1, that's negative because it's below the x-axis. The graph is below, and then again we're positive on the right side of the x-axis. So this is positive again. And what are we looking for? We are looking for positive numbers greater than or equal to 0. Where is this function? This function greater than or equal to 0. Here and here. I want the x coordinates to give me those parts of the function. So again, starting out here, negative infinity, going to this x coordinate right here, which is negative 2, skipping over the middle numbers, and then starting at 1 and going to positive infinity. So negative infinity to negative 2, union with positive 1 to positive infinity. Okay, and that's how you do it. It's all you have to do. You know, the sketch doesn't have to be anything fancy. All you got to do is make sure you get the right x-intercepts on there, and that it opens the correct way. And that's pretty much it. So you can do the homework on Schoology.